Tucked deep in the Indian Himalayas and the Nilgiri Mountains are some of the oldest, most intricate railway networks on Earth. They navigate near impossible geography, narrow ledges, dense forests, and gradients so steep they rely on rack and pinion cog tracks to maintain their grip. But pulling thousands of tons of steel up these slopes requires immense power. Right now, that power comes from burning heavily polluting diesel and coal right in the middle of these fragile ecosystems. It leaves these UNESCO World Heritage Sites trapped in a paradox. Surviving the mountains requires the exact fuels that are slowly choking them. India is currently electrifying its massive main rail network at a staggering pace. So the obvious question is why they don't simply plug these mountain routes into the grid. Standard electric trains require a massive, rigid footprint. They need wide physical clearances, heavy metal gantries, and an unbroken web of high-voltage overhead wires. Time to construct that kind of industrial grid across century-old narrow-gauge bridges and cliffsides is an engineering nightmare. More importantly, it permanently ruins the historic aesthetic people travel to see in the first place. The solution comes from the Integral Coach Factory in Chennai. They've built a completely self-contained train that carries its own fuel on board, requiring exactly 0 overhead wires, and they built it to massive proportions. This is a staggering 10-coach design engineered to comfortably move over 2,600 passengers per trip. To move that much weight, it utilizes twin power cars capable of generating an incredible 2,400 kilowatts of energy. This 10-coach configuration stands as the longest and most powerful broad-gauge hydrogen train set ever deployed. The secret to that power is safely hidden away inside the chassis. Each coach is equipped with 3 reinforced high-pressure hydrogen cylinders. That stored hydrogen is pumped directly into a fuel cell, where it mixes with oxygen pulled from the outside air. There is absolutely no combustion. Nothing burns. Instead, the hydrogen and oxygen trigger an electrochemical reaction, creating a direct, clean surge of electricity. That electricity directly drives the traction motors on the wheels. Any excess power is banked into onboard batteries, ready to deploy when the train needs a sudden burst of acceleration for a steep climb. Because the only chemical byproduct is H2O, the exhaust pipe doesn't release toxic black smog. It releases a quiet stream of pure water vapor. A single tank of hydrogen gives this train a range of 1,000 kilometers, and without large diesel pistons firing, it operates 60% quieter, a massive benefit for moving through wildlife reserves. But before a massive piece of new machinery takes on the high-altitude curves of Darjeeling or Kalka-Shimla, it needs a predictable proving ground. That's why the formal commercial rollout is scheduled for August 2026 on a completely flat 89-kilometer pilot route between Jind and Sonipat, ensuring the tech is bulletproof before it heads to the mountains. Building a cutting-edge hydrogen railway from scratch exposes a difficult economic reality. A standard electric train in India costs around 15 to 20 crore rupees to build. A single hydrogen train costs roughly 80 crore, quadruple the price. While the trains themselves are manufactured locally, the most vital components, the fuel cell stacks, still rely on imported parts, exposing the project to global supply chain vulnerabilities. There's also the problem of the fuel itself. Truly green hydrogen, extracted using renewable energy, remains scarce and highly expensive. Right now, the vast majority of the world's hydrogen is still produced using carbon-heavy fossil fuels. The train reflects a significant technical milestone, though its impact remains bottlenecked by the current cost and scale of global hydrogen production. Despite those heavy upfront costs and fuel challenges, the Indian government still approved a 2,800 crore rupee budget for this program. The reasoning becomes obvious when you look at the alternatives. This table compares the operating profiles of hydrogen, electric, and diesel trains. Electric trains have low running costs and 0 local emissions, making them the absolute best option for India's main rail corridors. But look specifically at the Heritage Hill Routes row. Electric installation up there is prohibitively costly, and diesel produces high emissions and loud noise. Hydrogen provides the exact heavy-duty independence of a diesel engine, but runs nearly silent with 0 direct emissions. The Hydrogen for Heritage initiative provides a targeted solution to keep India's most historic and fragile railways operational while preserving the environments they travel through.